It's a theory that sounds plausible to me, but the main sticking point is that object-oriented programming doesn't actually deliver these promises. You'd think people would have noticed sometime in the last 20 years, yet they seem not to have noticed. I'm also skeptical of the idea that management actually really inserts themselves in these technical decisions that often. I suppose once, say, object-oriented programming was well established and that became the pervasive norm, then yeah, sure, management would push towards doing what everyone else is doing so that they can draw from the larger talent pool. But otherwise, aside from pushing engineers to just go along with the legacy system and not rebuild everything, I just don't think that many business managers really care that much about technical decisions. I'm much more inclined to think that object-oriented programming is something that programmers did to themselves, and the question is then, well, why? I think a big part of the answer simply comes down to Java. When it was first introduced in the mid-90s, Java seemed like a welcome reprieve to many programmers. Compared to the alternatives, Java seemed really simple. For example, on the PC, this is what application development looked like. You had to use the Win32 API in C, and not only did programmers have to concern themselves with memory management as you do in C, but on top of that, Win32 just doesn't feel like the C that you would learn from books. It's not what you would learn from K&R. It's not what you would learn in school. It's all this excess, macro-heavy stuff on top that is really mystifying. Even the tools you would use to write C programs on a Windows platform, the Visual Studio tools, wouldn't be the same as what you would learn in university probably, where you probably had a Unix system, and that's what you learned. So it was already this platform with a quite high barrier to entry, but then also in this period it was undergoing this ugly transition from Win16 to Win32, and so you can begin to see why programmers were desperately looking for some way out. The only real alternative at the time in PC programming was Visual Basic, but that was another effective Microsoft platform you're locking yourself into, and I suppose otherwise you might use Pascal or Delphi, but that platform had its own issues. And so it shouldn't be too surprising that when Sun Microsystems came along and said, here's this free thing that everyone can use across all platforms, that got people's attention. And Java had other things going for it. It certainly seemed more accessible, just in terms of its naming conventions. For example, you look at the Java APIs, and you see things like file input stream, which is not cryptic at all. Yes, there are definitely issues in how abstracted many of the APIs are, and having to derive base classes to use the APIs and all that nonsense. But on first glance, on surface inspection, it certainly seems like a friendlier system. It's not like Unix, where you have stuff like IOCTL, which is you're supposed to know is input-output control, and other really horrible abbreviations. And then Win32 had the same thing. LPCTSTR stands for long pointer to a const tchar string. So even if you know what a tchar is and a long pointer is, you're stuck in this world where everything is cryptically abbreviated, and it's just this goddamn puzzle that you have to figure out at every step. Java came in and said, no, we don't necessarily have to program that way. We can write real programs that don't have to be horribly cryptic in that way. And then Java took things too far in the other direction, but that's, again, we'll get to that. Java also smartly had the C-like syntax, the curly brace syntax, so superficially at least it seemed familiar to programmers from C and C++, and it seemed like real programming. It has curly braces after all. And then the whole compilation to VM bytecode business was, again, very alluring to programmers trying to escape their platform headaches. And then Java also offered some very basic niceties like proper namespaces without header files. For Christ's sake, we still have to deal with header files to do our real programming in C and C++ at least 20 years after we should have ditched them. If for this one thing alone, I think it's worth giving Java some credit. It mainstreamed programming without header files. And then, of course, also very alluring, garbage collection. I know some hardcore low-level programmers out there will insist that garbage collection is never necessary, it's never a good idea. But whether or not that's the case, it's really hard to argue with the appeal. It shouldn't be surprising that the vast armies of people doing business CRUD applications wanted to stop thinking about memory management. Java also mainstreamed exceptions as the primary way to handle errors, and whatever problems this may have in practice, I think it definitely seems appealing. Because the alternative is ugly. The alternative is what we do in C and C++ of having to have an inbound error return value, or saving to a global and checking the global after everything you call. It's not pretty. Golang with multiple return in that style probably is the better way to go. But that's not the solution Java came up with, and so it normalized this other thing that seemed better at the time. I think some people also came to like the subject-verb-object nature of method calls over straight function calls, because, well, this is just what we do in English. It's subject first, then verb, then object. I myself don't find it all that appealing. I prefer consistency, and I think the distinction between subject and object in many cases gets very murky, which is one of the problems with object-oriented programming, as we'll get to. But this style of syntax in Java led to this convenience people, I think, since then have become addicted to, which is in their IDEs, it offers them, for this data type, what are my options? What can I do with this thing? It seems to enable a style of programming where you can just sort of browse. You don't have to hold all of the options in your head. You just have a vague notion of, well, yeah, I'm going to take that thing and transform it into this other thing. I don't remember exactly what the method's called. I'll just grope my way there using autocompletion in my IDE. Again, there's really actually no reason you couldn't have the same style of convenience in a purely procedural language. You would just have an autocompletion for, given this first argument, what functions take this type as its first argument. And it'd be effectively the same thing, really. But because of quirks of history and syntax design, this particular editing convenience has been implemented for languages like Java, but generally not straight procedural languages. And I think method autocompletion may actually largely explain why people sometimes claim that object-oriented APIs feel easier to use. It's because you can largely autocomplete your way through most of the usage. Another thing Java seemed to have going for it is that back in the mid-90s, this was the heyday of GUI programming, and it seemed really logical to map components as we see them in a GUI window and classes in an object-oriented program. That seemed like a very natural correspondence. This was the most tangible version of the real-world modeling which object-oriented promised. At the time, it seemed like a very plausible story, and on top of that, you have the virtue of Java being supposedly cross-platform with the Java Swing API, so you can write GUIs that will run on any system. They'll look horribly ugly, but at least, hey, they run on everything. You could do so-called RAD, Rapid Application Development of GUI applications like you do in Visual Basic, except in Java, you're not locked into Microsoft's platform. So the funny thing to me about Java is that I think in an alternate history, it could have had virtually all the same success, if not even more perhaps, if it weren't object-oriented at all. It could have just been a straight procedural language and would have had still a big long list of attractive selling points. We could have had all the same portability, the same garbage collection, the same exception handling, and so forth down the line without any of the object-orientedness. Or at the very least, without forcing everything into the mold of classes. You could have it in a language like Python, say, where there are classes, but also just straight procedural code if you want, and they could live side by side just fine. So there still is this question. Java aside, there seems to be some appeal to object-oriented programming in itself, and what is that? Well, I think very simply, if you go back to the 60s and 70s, as people were grappling with the problems of software systems getting larger and larger, people tried to identify units of code abstraction that were larger than individual functions and data types. It's natural to want to describe any complex system in terms of large-scale components. You know, if you talk about human anatomy, you don't explain it first in terms of microbiology, that would be nuts. We first talk about very major organs like the brain and the heart and kidneys and so forth. As software gets larger and larger, it felt like these units of code we were building out of, the base materials, these data structures and functions, they became smaller and smaller relative to the whole. Sadly though, the one general answer people could come up with of what is a unit of code abstraction bigger than a function and bigger than a data type is just simply a combination of the two, and hence objects were born. We took our functions and our data types and we associated them together into these larger units. We want to think in terms of paragraphs rather than individual sentences, and object-oriented programming seemed to have an answer for how we could do that. It's also very natural that as we build larger and larger systems and complex things, as much as possible we want simple rote rules to guide us. Object-oriented programming seemed to present a unit of abstraction and a set of guidelines whereby we could incrementally accrete larger and larger systems. This line of thinking is what led us to patterns, and then the so-called solid principles and dependency injection and test-driven development, and all this stuff which has subsequently been piled on by many people who insist that this is now the one true way to do object-oriented programming. But to me, all these best practices represent band-aids. They are compensation for the fact that the original vision of object-oriented programming has never panned out, and every few years there's a new ideology in town about how we actually do object-oriented programming for reals this time. It's very easy to miss this dynamic. I know I did for several years, because I think within all of these addendums to object-oriented programming, there's lots of mystical speech dancing around genuine insights, but it's not quite cohesive.